Well, good morning, everybody. Here's the plan for this Tuesday morning. What I want to do is I want to talk about how the pattern over the next probably 10 plus days is still pretty loaded in the North Pacific, sending really unblocked jet stream flow into the United States, which is going to result in more precipitation. We then want to talk about when that pattern might possibly shift and what the temperatures are going to do in response. We'll get to that about the middle of the video. And then at the end, to kind of stretch this out longer term, we're going to ask two questions. The first is going to be, what would it take to dry down a big section of the middle part of the country that has been extremely wet lately in order to get some progress done on planting? And then we're going to look at one year in particular that a user commented about, which was 2019, and kind of do a little compare and contrast and see what would it take to get something like a 2019 to repeat itself in the month of May. I'm going to finish this up with a bit of a global outlook as well. So the map I've been talking over is one I've shown you many, many times, but as I've mentioned, I've been working on some new mapping ideas. This is percent of normal precipitation over the last 2 weeks. And in the past, I kind of just said anything over 325%, let's just make it the darkest blue. And a lot of the stories we've been discussing kind of show up on this map, where we've been extremely wet, large part of the northern and central plains, getting over here into the western and part of the central corn belt, and down here into this part of the southern plains, getting toward the Mississippi Valley. That dry slot continues to show up quite clearly here on the 14-day percent of normal precip. We've seen drier conditions return to parts of the southeast and up the east coast. Not a major concern overall, except for the really dry conditions that have been showing up for longer than a 14-day time period in parts of Virginia toward the mid-Atlantic and then back down toward North Carolina. But the new maps, I hope you'll like them. I just made some adjustments. So now you can see all the way up to 1,000%, and it really just highlights these areas that are exceptionally wet. So take note, when you get into this darkest shade of blue here, that's 800 to 1,000% of normal precipitation in a 2-week time frame. So it's just hopefully a better way to illustrate this. Plus, I'm making all regional maps out of this as well, with numbers overlaid so that you can see them. I apologize, it takes me a long time to write that code, just given my other responsibilities, but we'll get it up there for you and get to agweather.com to just, I think, be a more useful resource as we go forward. All right, this morning, about 5:40 as I'm recording this, we did have very dense fog that is kind of lining up here along the Mississippi Valley. And of course, we just saturated a lot of this ground with heavy rainfall. And then this morning, if you take a look at the wind field, high pressure built in and the winds got calm. So the skies cleared out. We had strong radiational cooling. With all that moisture in the low levels of the atmosphere, we were able to get a pretty dense fog to form here. But if you take a look at some of the other areas, we've got freeze warnings out for the Snake River Valley. We also have them for this part of Northern California and southwestern Oregon. Strong winds coming out of parts of Montana into the Dakotas here. And you can also still see we have winter weather advisories. There's actually a winter storm warning here as well. So the setup of our pattern is still such that the Pacific is really driving systems into the west that are kind of still giving us that checkmark look across the country, that southwest flow, which is so critical to the way these systems continue to form. So as the sun was trying to rise this morning, here it is, you can see some of the fog in the valleys. See it right in through here? But I'd like to take you back to yesterday just to show you a couple of interesting things. As the severe weather cleared into the Gulf of Mexico yesterday, it was important to note that we could see better as the sun was setting some more of the wildfire smoke that is coming out of Mexico, which of course we know is quite dry. Other things to take note of: the large high pressure system still blocking the east, meaning that this system's front is not just going to plow through this area, delivering a lot of rain. And there was one quite interesting cloud feature I liked. It's right here. And it's coming across parts of Northern California, just screaming in that jet stream level wind pretty high. I mean, that's a very high, thin cloud rolling through there, but it's always neat to just pick up on these subtle features. And lastly, as we flip over to the infrared last night, you can see where the Gulf Stream is as well, because it was clear out there, so the infrared could see right down to the ocean without cloud obscuring that view. Okay, last 24 hours of total accumulated precipitation are shown here. So some rain finally moved into Tennessee and Kentucky, hit the Ohio River Valley, southern Indiana. This was an area that had missed a lot of the precipitation from the last several systems, but extremely heavy coming out of Texas into Louisiana and parts of southern Mississippi yesterday as well. We did add some snow, as we saw here in the northern plains. And as we just look at where this potential forecast is going to go, we go right back to the discussion on severe weather. So this is today's severe weather outlook. While the tornado threat is there, it is not as high as what we saw over the weekend. So this enhanced risk, I think right now, is while we do expect isolated rotating storms, this is more of a hail and wind threat than it is a tornado threat. Please don't misunderstand me. There is the risk of tornadoes here. I'm just trying to compare it to the risk we saw over the weekend, because this is that same area that got hit pretty hard. So this is the outlook for today on April 30th. On May 1st, we're going to go right back to Kansas. We'll take a look at how far back to the west these storms are expected to fire. This is where the enhanced risk is for tomorrow. And then on Thursday, again, we're going to continue to watch a broad area from Texas all the way up to maybe even this part of western Wisconsin for the risk of severe storms. But the atmosphere is just set up to deliver for a while. And what I mean by that is just take a look at how these systems are kind of lined up here in the North Pacific, trough after trough after trough, with no significant blocking feature to redistribute or amplify the flow, to slow it down and stop these systems, which means there's nothing in the Pacific, both north or south, north or equatorial, forgive me there, that's stopping the flow coming across the United States. And that's why we still look out there in this near-term pattern and see quite a bit of activity. So we're looking for anything to disrupt this. And let's go have a look at the top-down view on the planet, looking down at the North Pole at the jet stream pattern. All right, so as I play this forward, you're going to see just kind of like we often call it a parade, right? There's going to be just several troughs of low pressure entering the country from the Gulf of Alaska. So this is through Wednesday into Thursday, late this week into Friday. You see them just sneaking through here, really just hitting the northwest and going out across the Rocky Mountains and moving their way toward the Great Lakes. So all the way out, 10 days from now, we're still looking at that same kind of pattern, which means that first week to 10 days of May continues to favor this action. Now, I feel that we're at a point where predictability is pretty low at this point as we transition into May, meaning that I would not expect anything beyond a 7 to 10 day forecast to verify. I'm still going to show you what I think, but I don't think it's going to verify very well. And one of the things we've been discussing is out there around May, well, it's kind of shifted a bit. May, let's call it 10, 11, 12 now. The pattern does appear to give us a different look. And that look is such that there's troughing here and here, but we no longer have West Coast troughing that's ripping off storm systems. So the model, keeps kicking it down, in the forecast. It keeps pushing it out there farther and farther. But if we end up getting flow that does this and comes in a broader trough at this point, that is a signal for drier weather in the central United States. All right, if troughs live over the Four Corner states or in the Great Basin, then the central United States has storm system after storm system after storm system. That is the flow that gives you that check mark look I talked about. But if it starts to flip over and come over slight ridging in the west, we get northwest flow that's convergent flow on the backside of a trough, and things start to show a little bit more of a drier signal for a broader part of the country. Now, also at this time period, we've been using the artificial intelligence to try to understand the depth of this trough. I want to show you something, though. We had seen that trough setting up May 8th, 9th, and 10th, and it's now a bit farther. It's no longer 8th, 9th, and 10th. It's more like 10th, 11th, 12th that it starts to deepen this trough that's here off the East Coast, or along the East Coast, along the eastern third of the United States. And so, I've given pretty high praise to the artificial intelligence forecasting system, but it is not infallible, right? So clearly, timing issues are still going to be present, even with these new AIFS forecasts, despite its success earlier this spring when we were using it. But the point is still to show that out there around May 10, 11, 12, 13, somewhere, we're expecting deeper troughing. And I've looked, and right now, none of the models are bringing in like a very, very late frost event with this deep trough. Cold, cool, yes, but look over the 540 line. It's just as a benchmark. That's all I'm going to use it as. It's way up here. And could we get some lows that touch, the mid to upper 30s in this region? Absolutely. But I'm looking for the risk of getting down there into the low 30s, and I just haven't seen it yet. But I'll watch. We'll be keeping a very close eye on the potential for that. But again, I want to stress one more thing. When ridges form here and flow comes over the top, something like this, that's a drier signal overall. So we're going to be watching out for that. But in the next 10 days, it's a lot of wash, rinse, repeat of what you've seen as of late. So let's get into the models here. We're going to pick this up this morning with the high-res NAM. We're going to watch one low curl up. Notice how this front really breaks apart, doesn't deliver much to the east, a lot of scattered precipitation out of it. High pressure here, and just the fact that this low lost all of its upper level support as the next one forms. So by this evening, just keep an eye out on this whole region for the risk of isolated severe storms. That's what we're going to watch. And that's where the models have it at 6 o'clock. Of course, you know the timing will be different. That's why we watch radar throughout the day and nowcast rather than forecast at that point. But I want to keep a close eye on this area tonight for the risk of those strong to severe storms. Then we get into the overnight hours, and the frontal boundary kind of lingers here. It catches the next wave that's coming off the backside of this. Remember this broad trough in the west. And so by Wednesday morning, our attention is going to go back to the plains. We're going to see snow in the Rockies. We're going to watch the next wave come out in the evening, and the big question will be how far back into Kansas are we able to deliver the heavier precipitation? Because as we started with, you can take note of just how dry this quadrant has been over the last couple of weeks. It's not just the last couple of weeks. In some places, it's months on months of dryness. But again, we look here at trying to figure out where those storms could get, and the models are not perfectly resolving that, of course, but they're attempting to deliver quite a bit more rain into parts of Nebraska, possibly Kansas, certainly down farther to the south of the Red River Valley, and throughout a big section of the upper Midwest. As we saw yesterday, on the backside of this upslope flow, getting here to some snow into parts of Alberta, out of Saskatchewan, and into Montana as well, which again, I'll just say it has been on a wild ride with temperatures this spring. Finally, you note that all the way by Thursday, the next bit of flow is still coming into the northwest. So coastal Oregon here, picking up some rain, Cascades and interior of Oregon, possibly seeing more snow as well. And that's just the next system that we'll be talking about. All right, so let's do what we've been doing. I really enjoy this. I hope you have as well, the 5 model comparison. This is such an amazing time to be forecasting, that we have these 5 models that show, really good statistical accuracy, good enough to be using. And we're going to start with the artificial intelligence one, as we normally do. So that's a 7-day outlook from the AIFS. A lot of the same narrative we've been carrying throughout this week. This is the WPC. So this is the Weather Prediction Center's forecast. This is now the National Blend of Models. Here is the European. And then here is the GFS. And so if this looks a lot of like I said, the kind of wash, rinse, repeat idea. In other words, the pattern hasn't changed too much. It really hasn't. Again, real quick, artificial intelligence, WPC, National Blend of Models, European model operational, GFS operational. And I want to show you something. The European model, everywhere that you see these colors, is wetter than the GFS. So a lot of that's in the northwest and this part of the northern plains, upper Midwest. But take a look at the different placement of the heavy rains out of this next system for parts of Texas into Oklahoma and then back here. And again, why I stress this is just take a look at the recent precipitation. Let's go to my new map here. We've got some parts in that region of Texas that are 300 to 1,000% of normal, 3 to 10 times the normal amount of rain just in the last couple of weeks. So we'll watch out for that quite carefully moving forward. One other thing to point out, all of the models are attempting, let's just pick one here, to bring some moisture. It's not a lot, but some moisture into that really dry part of the mid-Atlantic. I'm thinking a lot about Virginia here in North Carolina, which have missed recent precipitation, have not yet shown up fully on the drought monitor, but it's getting quite dry in this area. Okay, so a quick model comparison here. GFS left, European right. We've watched already this second system here coming out. So this is now Thursday morning, Thursday afternoon and evening, where we're expecting kind of our last round of severe weather from this system. It then curls up here right along the border between Manitoba and Ontario, and again drags a front right through the eastern Great Lakes, clear down to the lower Mississippi River Valley. That's in both models, although the GFS is a bit farther in progression. So by Friday night, we are also watching our next low come into the Pacific Northwest. We're going to see where that one goes this weekend. So you can see it digging in here. It's in both models, a little bit farther to the south in the GFS than the Euro. While that one comes in, the front tries to get over here to those dry areas along the East Coast we talked about. So they need that rain coming through. And then we're going to keep an eye out on where things go by this weekend. Now just take a look at this to show you that the models have fallen apart with their ability to kind of predict the same systems. And this is why I said predictability is low right now. This is just this upcoming Sunday evening. And already we can see a difference. There is something in the midsection of the country in both models. There's a system exiting, coming up through Hudson Bay to the Canadian Maritimes here, leaving a front across the east, but different kind of view of the rainfall. But take note of this system that's in the European that really doesn't seem to be showing up at all in the GFS. As we play forward, that's a large system that curls up there Monday into Tuesday here, delivering quite a bit of heavy rain. But this is only a week out, and the GFS has got a different timing, a different look. It's trying to make a system here, but just to show you that they already start to fall apart by days 6 through 9 in the forecast. Now, what we'll do, and this is why we look at all the models, is we're also going to do our normal, well, let's have a look at the ensembles, because this kind of gives us a better idea on the distribution of precipitation by accounting for the variability between all these runs. That's why we do this. So this is the look for a chance of an inch of rain in the next 10 days. And you look at this and say there's a lot of places that need this, and there's a lot of places that don't want a single drop of this and need some drier time to really get things going. But this map probably looks quite familiar to you because it's been basically a copy of what I've been showing for the last 10 plus days. If we step it up to the really wet conditions, I just got a new model run in here. Thought I was going to beat it this morning. Whoops. CRC. Now let's go back to 2 inches, and there we go. This is where we are expecting in the next 10 days the highest chances for 2 inches. It's that same story. Right in through here, the farther west you go, the drier the risk is. In fact, looking at the dry regions, this is the chance it's staying under a ½ inch over the next 10 days. Just to point out an area, these numbers keep dropping here, which is great. We need to get more moisture back over here into this part of the East Coast. All right, where does this pattern end up? Now, I'm just going to play this for you quickly, but these are jet stream level winds. And this is through the end of this week, playing into the weekend, getting out there into next week. I mean, can you continue to see it? There's this feature coming in. There's some subtropical flow coming in, but there's that characteristic checkmark view. So as I play out past May 7th, 8th, 9th, and 10th, it's still there. See this? So that's why we're waiting to get past the 10th, 11th before something starts to give us a little bit different look. And that's why, as I say, that first week of May, getting into the second, can we get the flow to come around like this or split a bit so that we have some flow out of the northwest to maybe start to slow things down? But I'm already out here at day 14 in the forecast. So that's why the week 2 forecasts, which are shown here, still look wet across the same regions. There's actually pretty good ensemble agreement for week 2 between the CPC, the European, which is the middle map, and the one on the right where the cursor is the GFS. So overall, I can't necessarily argue that could be the likelihood, highest likelihood of the pattern going into week 2. So we need to ask, when is this going to shift around? Will it be past the middle of the month, or are we looking at something where the models want to look for a pattern change, but persistence wins the day? That is going to be the most challenging thing about May, and that's why I want to talk about a year like 2019, which we're going to do in a moment. First, some information on temperatures. This is what April is going to look like in terms of temperature compared to average. Most of the West spend April cool. We're behind on the accumulation of heat units in a lot of the West, especially California. And if you go east, we've had quite a bit of warm days. But nearly every day when it got warm, it also got extremely windy in this area as well, given the contrast between U.S. and Canada temperatures. So our frost risk over the next 7 days shown here. Again, this only gets us out there to May 7th. So we're just looking at who's cold and where we expect those frosty events to be coming in. So a lot of that's in the west where the troughs dig, and at times right here in the western plains of the United States, western and northern plains. Looking at max temperatures, this is where we begin today. So this is just an excellent moment to talk about a feedback mechanism. Where that dry air is and where it has been, you have much more efficient transfer of solar energy into dry soil. If there's water in the soil, the first thing that the sun's energy does is evaporate the water. And the evaporation process, right, is a cooling process. If you don't have that, more of the sun's energy gets absorbed by the soil, which then transfers, via conduction into the lower atmosphere, the first couple of inches, and then convection above that, meaning that this is where our heat is going to be. That's just to show you that the models see this very, very well. But north of this, cold. Parts of New England still cold today, but that is a feedback we can't ignore. Now, this can also be made worse by stronger westerly winds coming down slope, which are even drier, that get into this area, but just want to point that out. That's Tuesday into Wednesday. See the same feedback mechanism happening here. But by Thursday, we start to shift warmth. The winds dominate by Thursday. So you see this is where the pattern is going to take away that local effect of solar heating. And this is what the temperatures look like on Thursday. By the time we get into the weekend, this is Friday into Saturday, early next week, Sunday, Monday, and overall over the next day 5 through 10 time period, we still keep that cool west and warm east. I want to make a comment about this because in March, when I was looking at what April was going to be, and in the beginning of April, I kept saying snow feedback in the model, snow feedback. I was wrong. What's really kept this cool is the fact we keep getting flow, from the Gulf of Alaska that's dropping troughs that make the turn. And I thought it was a model feedback issue, but it was actually picking up on a real signal. Once we get out there past day 5 through 10 to day 10 through 15, the GFS took a little bit of a cooler trend in the central part of the United States. As we look here at, the end of the first week of May into the second week. The GFS did this. The European is still has a different look. This is day 5 through 10. So certainly similar to this. But day 10 through 15, we don't quite see the extent of the cooler air in here as suggested by the GFS. It's there, but it's still mostly anchored over the Intermountain West. And we just continue to keep that cooler bias there in the models. So every time I've seen them kind of go over warm here, we need to just remember that their consistency with over forecasting the temperatures in this region has been pretty relevant or evident, over the last several runs. It's been missing it. Okay, what's longer range? Well, this is the latest ECMWF outlook for May 7 to June 7. And I want to show you why I think the models have a persistence bias in them. And let me rephrase that, an initialization bias, and are not actually picking up on any solid signals. Because if I just show you the run yesterday, it looked like that. The run the day before, this is all for May 7th to June 7th. That's the run before it. Here's the run before that. And what I'd like to do is average all of these, honestly, to get a better look. But the reality is they're bouncing around quite a bit overall with this pattern. So I'm going to come back to where we started and say this is a really wet look for a lot of places, except those areas we focus so much on that have been dry. And I'm going to think about the whole of the central United States, just because that's where this focus has been for the really wet conditions. And I want to reconstruct for you May. Now, what you've got here is for the central United States National Weather Service region. We're looking at every May total precipitation since 1895. I did put a trend line on it since 1970, just a starting point more than 50 years ago, and it is wetter. It's up by about 1/10 of an inch a decade. That's what this trend line, the slope of that trend line is. But what I would like to know is, what is it that gives us these drier Mays versus like a May like 2019, which is the wettest on the record here. All right. So what's nice about this is you can come down here and you can kind of rank things. So there's May 2019 wettest. The second was 1995, 15, 08. You can see you got all these years in here, and here are the driest. And we want to look at some of these dry years and do some assessment. Now, when I do my historical analysis, I only choose stuff like post 1960. And there's a lot of reasons for that, but these are the years that I'm going to use. These are dry May in the central United States. And I want to show you what would have to change as you watch my next several forecast videos for May to go over dry in the central U.S., where it has recently been extremely wet with a lot of severe weather. Because these years stitched together, there's the dry ones, were that way here. So take a look at this. This is what the jet stream has to do. We need to get a large ridge to form here and to form there. We need to get the pattern to be way more amplified than it currently is. You see, when I started off this video, I said, look, no block, right? I mean, it's just flow. Do you not see? There's no high amplification. If you want to have a May that gets dry, the pattern has to get more meridional. Ridge, deep trough, ridge, deep trough. And what's interesting about this is that this central Canadian ridge, which we had last year, which 2023 is in the analogs, this is what it tends to do to the flow. Now we're looking at mid-level winds that are anomalous. This does not mean that every day around that big ridge here, they flow out of this direction. You have to have a very strong ridge for that to occur. Last year we did. And last year when that happened, where did all the rain go in May? It came to the western plains. It came down here to the southern plains. I mean, parts of Texas a year ago, right, saw, some places I think picked up over 20 inches of rain. I have to go back and look at that in a month. While the Midwest, Canada was burning. The Midwest was extremely dry. No precipitation to be had. All the storms were way down here to the south where the flow is. And my point in showing you this is that this is the kind of highly amplified pattern you need to make that occur. Now, what does the MJO need to do? It needs to live in the Pacific. Like, it needs to be a dominant MJO signal somewhere out phase 781. Let's call it 781, right out here. And here you go. That's what the MJO is up to right now. So you say, well, why can't you predict this, May? Why can't you give me a solid picture? Well, El Nino doesn't matter. La Nina doesn't matter in May. Every year in May, El Nino or La Nina is transitioning. Spring is always a transition time period for El Nino, La Nina. It's never a peak time period. Does that make sense? So we can't use it. So we have to look at these subseasonal factors, and the MJO is one of them. And right now it's in phase 4 and it's going to sweep around. If it was doing this, then we'd have something to talk about. I'd be like, yeah. It's going to not stop. It's going to stop. We're going to see a major shift over toward, really dry conditions. Or if it was going to do, this, we'd have a whole different story. Now, let me show you what I mean. MJO in the longer range. You want to know why the European models bounce all over the place? That's the European extended forecast, like the weeklies I just showed you. That's their prediction of where the MJO is going to live. And it's just kind of hovering around in this area. Not any of this, and certainly not any of that. So what this means is the likelihood of having a repeat of 2019, which here are the precipitation ranks in May for 2019, okay? The likelihood of having that is pretty low as well, because we don't have the strong MJO signal. We don't have the right trough ridge pattern currently setting up. And what those would look like would be something like this. Let's skip that and get here. You see, in 2019, it was highly amplified. But look at the difference in the placement of the trough ridges. There was a deep trough here, a large ridge in the Gulf of Alaska. The flow was blocked across the west, highly amplified. And at times over this ridge sitting here, we saw wind speeds that went from California to Maine at 250 miles an hour. That is southwest flow. And that is, that's like non-stop storm systems. Day in and day out, just doesn't quit. So for comparison, where do I have my other one? There you go. This is what things look like if we go dry. Southeast trough, Canadian ridge, Gulf of Alaska trough, This is what it looks like if they're wet. Shift the whole thing. It's a massive phase shift in the pattern. So which are we going to have? Neither. I don't think we're going to have either. I don't think May is going to land on the extremes of dry versus wet. But a problem is I don't know where it's going to land. I have a lot of analog support that keeps looking at maybe a drier signal for the Midwest once we get into May. We just saw the new European model say, maybe a little drier in through here. A little drier across the south, and a little wetter here in this region. But this has bounced around so much, we can't really rely on it. And so therefore, we're going to have to live through this together 1 week at a time. And the reality is that your next week before we get into this looks something like that. And can we get a shift in week 2? Possibly. I think it's coming late, like May 13th, 14th. All right. So with all of that uncertainty, where do we finish? I want to show you this. May of 2019 would be something that most of Brazil would enjoy. It was a wetter than average May. Wasn't one of the wettest like 2009, but it was wetter than average. And right now, as it stands, they're nowhere near that. Very dry, almost no precipitation. We talked about this all week in this area. You have the flooding that's still down here in parts of southern Brazil, really hitting Santa Catarina to Rio Grande do Sul, Uruguay. Still better storms in Argentina. But this area is very dry. We have decent rains coming out of Queensland into New South Wales. This is important kind of fall rains in this area. Flooding remains along and south of the Yangtze River. This has been a constant theme. And the dryness that we've seen in parts of the Russian wheat belt seems to be better rains as you get toward Turkey down here, but this still needs to be watched carefully. Much of Europe is on the wetter side of things as well. So I just wanted to pick up on some of these important things and just let you know there's still flooding in the the Middle East, in this area that we need to keep a discussion going about too. So I'll stop there, and we'll look forward to another update tomorrow morning. Have a good one. Thanks.